Hi, my name is Robert Guderian, and today we are talking about doing math. Um, Last class, I alluded to the fact that computer science has a lot of computation, which sounds obvious when I pronounce it like that, but is not actually obvious on the outset. Um, there hopefully isn't too many surprises in this lecture because most of this follows the math rules that we've seen to date. There's a few different ones and a few things that we'll have to point out, but in general, you should be pretty comfortable. For instance, here's the mathematical operators we're using: plus, minus, star for multiply, and slash for division. And if you look over at your number pad on your keyboard, which might look like that, you'll see that they're just on your number pad. Hey, that was easy. And they work pretty much how you'd expect. But the question is, what data types are returned? Last class, we talked about integers and floating point, which are for decimal numbers. Are these treated differently? Well, I mentioned that the interactive console is actually a pretty useful tool. This is one of those things that's useful for, and where you're questioning what gets returned, because I can just say 1 plus 1, and it will happily say 2. And if I say 1 plus 1.0, well, what should be returned? Well, it's going to be a floating point number, so 2.0. And that is how Python will tell us that it's showing us a floating point number instead of an integer. And you're looking at this, it's like, well, it's 1.1. Why would it return a float? Well, it's for consistency, because if I said 1 plus 1.1, well, then, yeah, of course, that should return a floating point number. That only makes sense. But to a programming language, it wants to be as consistent as possible. It doesn't want to suddenly switch. It's like, oh, I see this as an integer. I've got this for you. I know better than you. I'm going to make this into an integer for you. That'd be actually a pretty terrible thing, because all of a sudden you'll have floats and integers and they're bouncing around and something weird is going to happen. So this is for consistency within the language, that if you do addition or subtraction, and one of them, any number of them, and we can have like a whole number of these, right? 1 plus 1 plus 1 plus 1 plus 1 plus 1. Those are all integers. It's going to return an integer. But if I press up and subtract 0.0, which is literally nothing, or I apparently add 0.0, the result will be a float, because there's at least one float. So there could hypothetically be some kind of number that is within the decimal range or behind the decimal point, fraction of a number. So it's going to say, okay, I'm going to give you a float in return. And there is actually some danger here. If we were using, if we're trying to make a very precise number and we're using some fancy math to make sure that we can keep more than 16 digits of precision, and we add in one float, all of a sudden, it's going to limit that range down to 16 digits of precision, which, again, is a whole bunch, but maybe we need more. So what about multiplication? 2 times 2. 4. Neat. 2 divided by 2. These have all been integers. We're so happy. Oh, no. So, unfortunately, we have one outstanding one where if we divide, we get a floating point number back. All the rest will use integers, unless there's a float, then it puts in a float, except for division. That one's going to give you a floating point number back every time, which is odd. This is actually something that is a very Python thing. I just went through some slides and got to here. Because generally, in every other programming language I've seen, if you use division, it'll actually still return you an integer. So what Python has done is change that command. And this is how other programming languages work out of the box. And then if you want to do division with floating points, you have to have at least one floating point in there, like everything else. What Python has done is add a new operator that is //. This is called integer division, and when you're very excited at programming languages and you're taking Comp 1020, you'll say 5 divided by 2. Everyone knows what 5 divided by 2 is. Of course it's 2. Oh, sorry. 2 slashes. Oh, my joke is ruined. So this is integer division. Integers don't have any decimals. There's nothing less than a whole number. So 5 divided by 2 is 2.5, but that everything after the decimal is truncated. Gone forever. Do not pass go. Do not collect $200. You're gone. Which is interesting. In other programming languages, I say that a lot, and I apologize. You'll get busted by this. I get busted by this to this day. Forgetting that division between integers will return an integer. Except in Python, / will give you that kind of functionality, which is really terrible because sometimes it doesn't matter. So 6 divided by 3 and using 2 slashes, so the integer division, is still the correct answer. So it would be anytime we actually have something fractional is where that tends to go off the rails. There is also an interesting one. So now that we have the integer division, well, this is like old school division. This will return the remainder of this division. And this works with integer division. So think back to, I want to say grade 7, where you're doing long division for the first time. That was a long time ago for me. I think it's about grade 7. So 5 divided by 2. I'm going to jump over to here. Sorry. 5 divided by 2 is going to be 2 for reasons. But it's remainder 1. So if I say 5% 2, it's going to tell me that indeed the remainder is 1. That's what this does. And for the mathletes, think back to long division, you'd have done all of the dividing. So I'm going to jump over to my iPad here. And let's actually do this in the way that we would do it. So we would say you have a 2, pen, 5. Ooh, this feels weird, doesn't it? So you have to put a 2 here, and you multiply that over to here to get a 4, and then you subtract those. And you would say the answer is 2, remainder 1. This is what we use for modulus division. That's how we can get that back. Then we can actually recreate, because math is beautifully symmetric, we can recreate all of our numbers. So our denominator times our quotient plus the mod will give us our numerator. That's for the mathletes in the room. If you really jam on math, you'll be like, yeah, all right, now it's all symmetrical. We're happy. For the rest of us, which includes me, that's just nice to know. Okay, modulus will pop up from time to time. And generally we kind of abuse it to get some results that we want. It's just something that you'll need to remember, and you'll be excited when you get to see it. The other stuff is fairly easy. Exponents, there is a special operator. It's 2 stars. So 2 to the 8, and that'll be happily give me 256. Very exciting. Powers of 2, of course. There is another operator. If you like these, this is one of the built-in functions, which you don't have to know yet. We can say pow 2 to the 8 and get the same result. You'll hear me say this a few times in this course. Know both. Be able to read both. Use your favorite. So we tend to have a favorite way of doing things. And that's fine. Keep on using that. Generally, you'll only use one, but once you see the other, you'll have to know how to read it. And generally, it's kind of easy. And excitingly, Python does exactly what you would think in terms of order of operations. So if you are being crazy and not using your brackets appropriately, you would have to read this. Python will do it right. So BEDMAS, if you've forgotten, is brackets, exponents, division, multiplication, addition, subtraction. And that is the order of operations we do in math, and Python respects that. Brackets exist. Use them liberally. Programming languages, the code we're writing is for human beings, us. The computer can read really messy code and run it just as fast. But we have to be able to read it too. And if there's a problem with it, we have to be able to read it and understand it. So when you're writing code, write it for you. Or in your case, you're writing it for me and the people who are grading your assignments. And making it clearer, using lots of brackets, and making sure that it's readable actually does matter. So use brackets. It's easy. It's good. It doesn't make it any harder for you to program, but when you go back to read it, it's going to make it a lot easier to reread. As an exercise to yourself, in 2 weeks from now, look back at your assignments you're writing right now, or assignments, quizzes, labs, anything, and try to reread them. So your own writing, try to reread them, and you'll find out that it's actually kind of hard. So, summary overall, math is math, and Python does math things for us. Don't be a hero. That's me being a little bit snarky, and I apologize, but don't write complicated code. Some people think that the fewer characters they have, the better, the faster it runs. That is not true. Use very clear mathematical structures and break things up, and I'll show you how to break things up next class. And use lots of brackets. Again, programming languages are for humans, and not just humans that have insane abilities to read code. It's just should be clear. The math you see in code today should be obvious, just given that you have grade 12 math under your belt. Thanks for watching today. Next class, we're going to talk about variables and how to store our results, which is the big step that we take in going from math into computer science. Thanks for watching.